When you are writing code, are you doing it right? That's the question that worries a lot of people, and it should probably be at least something that every developer thinks through. Design patterns are best practice concepts that we can implement in our code to make it better in some way. Think of them as guardrails that keep our code safe. In today's video, we're going to be looking at the second entry in the famous SOLID principle. The O stands for the open-closed principle. It states that objects should be open to extension, but closed for modification. We're going to look at what that means practically. We will also discuss when this principle applies and when it does not, and how far we should take it. For those of you who don't know me, my name is Tim Corey, and it's my goal to clear up the confusion and frustration around learning C#, because learning software development shouldn't be so hard. If that sounds like something that would interest you, I think you would benefit from subscribing to my channel. You'd probably also benefit from joining my mailing list, where you get exclusive content and insider access. The link is in the description below. So let's start the conversation on the open-close principle, which we're going to call OCP from now on, by looking at some code. As you know, instead of doing PowerPoint and cool images to try and represent this principle in theory, I like to dive into the code itself to see it in action in the real world. So here I have a project I created in Visual Studio in C#. Now the principles of this video apply to any software development language, but since this channel focuses primarily on C#, that's the language we're going to use. So I have here one solution, two projects. I have a console user interface, and I have a class library. And if after this video you want to see the source code, no problem. There's a link in the description below that will take you to a blog post that I wrote that has the download for this project, as well as some snippets pulled out to kind of highlight what we did. So the job of this console user interface is fairly simple. What we have here is we're creating a list of people. We're calling them applicants. Okay, so this person model is just a very, very simple first and last name. That's it. So we're going to create 3 of these people and add them to the list. Now, if you haven't seen this before, in one line, I'm initializing my list of person model and adding 3 new instances of the person model to that list. Next, I'm newing up a couple of items. First of all, list of employee model, which is right now empty, and this account processor called accounts. So let's look at employee model first. Employee model has 3 things: first name, last name, and email address. Now again, this is a demonstration. It's not a full featured application, but I want to give you something that you could actually kind of see and think about in the real world. So what's going to happen is this account processor, it's going to take these people and it's going to convert them into employees. Think of it as these people have applied at our company and now we're going to give them jobs. And so because we're going to hire them, we have to give them an employee account. And so we'll take their information that we have, the first and last name, and we'll create an account, which again is simply first and last name and an email address. And I have a tool to do that for me. It's called the account processor, and it's got one method in it called create. So let's look at that. Under accounts, we have this method called create that takes in a person model and returns an employee model. And all it does is creates a new employee model. It adds the first and last name from the person model as the employee model's first and last name. Pretty simple. And then the email address, it says, okay, well, take the first, that substring 0, 1, just as the first letter of the first name, and then right away the last name, and then at acme.com. I just chose Acme at random. That's a big Looney Tunes fan as a kid. So if Tim Corey comes through this, we're going to get T for my first initial, and then Corey, so it's going to be tcorey at acme.com is my email address. So that's all it does. And if you look down below, we have a for each that loops through the now created employees. So I first looped through and took every applicant and turned them into an employee by doing create and then add them to the employees list. So I take every created employee and I just loop through and say, show me your first and last name and your email address. That's it. So if we run this, it's pretty standard. Let's actually run that again so the font's a little bigger. We'll change the defaults, and there we go. So it's pretty standard. It says, Tim Corey has now tcorey@acme.com. Sue Storm has sstorm@acme.com. And Nancy Roman has nroman@acme.com. All right, so that's our setup. That's where we're starting from today. Now, the open-close principle says that we should have the ability, and let's just focus for right now on the accounts class. That's going to be our focus for today. That this should be closed for modification, but open for extension. Okay, so what that means is that we shouldn't be changing this stuff once it's in production. Okay, it works. So if a new situation, a new scenario comes along, we shouldn't have to change this. We should just extend it. But let's see first what that new scenario might look like. So let's say this is an application that's running in production. We're turning applicants into employees. It's processing. That's great. Probably its account method's actually doing more things. We're just, again, right now simulating that it's doing more. So we're creating all this account information. That's great. But the boss comes to us and says, well, actually, we need to make a change. And he says, okay, what's the change? Well, some of these employees coming in are management. And we want to have a way of identifying that an employee is a manager. Now, right away, you may be thinking, well, we can create a different class called maybe manager model, where that inherits your employee model but has extra managerial stuff. We could do that. We could go really deep into inheritance, which can cause some nightmares. And that's really not the focus of this. So I'm going to say we're not going to go into changing everything and how we do things. We're not going to implement some kind of inheritance system. We're not going to have multiple layers of things. Instead, what we're going to do is all we really need is to have 2 extra properties here. Actually, there's 1 extra property right now. The 1 extra property is going to be this. It's going to have Boolean that just says is manager. That's all I really care about. And the one other thing we're going to do is we're going to set this to have an initial value of false. So by default, you won't be a manager. Now, right away, you may be thinking, wait a minute, didn't you just violate OCP? And in some ways, yes, I did. Because this class was needing modified. It's an existing class that's running, and I modified it. And this is where you need to start talking through when is it a good idea and when is it not a good idea to implement OCP. And the very first thing I want to talk about is if you're in the development process, this doesn't really apply. And by that, I don't mean you shouldn't design your application to be compliant with OCP, but you're in the development process. Things are going to change all across the board in your development, and that's okay. What you want to do is once something goes to production, the only reason it should change is because there's a bug in the system. Or at least that's the general rule. And that would still be okay because obviously it's not functioning the way it's intended. Therefore, it should be changed. It needs to be modified. But in this case, I'm making a change that is a minor change, and from my perspective, it's okay. And here's why. If I run this application right now, having added this Boolean, watch what happens. Nothing has changed. And the reason why is because I'm not depending on this property in here. It doesn't change how my processing works, nothing. Okay. Now there is some changes and it does require a recompile, but it would anyways. So with this being a minor change, I'd be kind of okay with let's change the model. It's okay. But you can say, you know what? I don't want to do that. In which case I recommend changing the model anyways. But instead of changing the model here, you just create an interface for this model and then create another interface called, say, iManager that has the extra property or something like that. So there's ways you can do it. It all depends on how much of a change it is and whether or not it's going to cause some breaking issues down the road. So in this case, it's not going to cause breaking issues. So I'm like, you know what? It's okay. But what I can do here is I can modify my console output just to reflect whether or not they're employees. So I'll do a space and I'll say, managers. I'll say is manager and then the value. All right, and that's just more for our purposes so we can see whether or not they're a manager. And of course, all three are false. They're not managers. So the bosses come to us and says, we need a manager flag added. So you come in here and say, okay, well, the accounts processor needs to somehow know that they're a manager. And that means we need to tell it some way. So you can come here to the person model and we'll need to add some kind of identifier. Well, let's do this. Let's create an enum. So we'll add a new class. This is how I do enums. I call the class enums, and then I delete the class itself. Okay, not the file, just the class. And then I have a file over here called enums that always has all of my enums for a given section. That way it's really easy to find, and I don't really think that enums need an entire class file dedicated to them. But that's, again, up to you. So let's create a public enum, and we'll call this the employee type. And we'll start with a general employee, which we're just going to call staff, and then we'll have a manager. Cool. So now over here, we can say prop, and it will be that employee type. And we'll just call this type of employee. Don't just call it type. That's a little too on the nose. It can cause some conflicts in naming. So let's call it type of employee. All right. And again, by default, let's go ahead and set this up to be a staff member. So again, nothing has changed so far in our application. If we run this, everything still runs as expected. So again, it's another one of those changes that doesn't really break anything. But we need to have some way of saying, okay, if they're a manager, we need to set that flag to true. So this is where that open and close principle, we want to really target in on this and look at how it can help us. So in here in this logic, we now say if, and this is person dot type of employee equals employee type dot manager, then output dot is manager equals true. Okay. So that now makes our change, but we have violated OCP by modifying this method. So what we can do now is, just to demonstrate this works, let's set Sue to be a manager. So our type of employee equals manager. And now if we run this, sure enough, she's been marked as a manager. So it works, but we've had to modify the code that was running just fine to make a new change. And now our manager comes back to us and says, you know what? We actually have a third type. That would be the executive. And so you say, okay. So you come out over to enums. We're going to add executive. Cool. And you go to your employee account, employee model, and just to represent it, we're going to say public bool. I probably should have done a prop. There you go. Bool is executive. And again, not a huge change. It's not going to break anything. If we run this right now, nothing changes. And if let's go over here to the end, and we'll do the same thing as before. We'll say is executive. emp dot is executive. And again, that just demonstrates to us whether or not we've processed this person as an executive. And both of those are marked as false. So we've got this issue now we're looking at and saying, okay, now we've got to modify existing code which already works. And that's in this class. So we go, okay, so now we have to have, another if statement. And then we have the brilliant idea, wait, no, we don't. We could comment this out, and we can do a switch statement. So we say switch on person.employee or type of employee. And that's the cool thing. You hit enter, and it creates all three of those different levels because that's the enum. And you say, okay, for staff member, we're going to do nothing. For manager, we're going to do output. Let's pretend like we forgot to do this. Just bear with me. Go executive. Okay, we need to do output dot is executive equals true. Cool. And we hit start, and this is what happens. Everybody's false. Well, Sue was a manager. What happened? Well, we forgot to put that code back in. We took it out because we were going to do it a different way. And so we took code that was working in production that we had relied on, and now all of a sudden we've had to modify it and reintroduce bugs into it. And that's a problem. So we have to come back in here and say, okay, output dot is manager equals true. And you also say, you know what? Actually, an executive is a manager, therefore we should also say is manager equals true for executive. And now we're back to working for Sue. And let's go ahead and change Nancy Roman to be an executive. And we'll hit F5. And now we have Tim Corey is nothing, just a staff member. Sue Storm is a manager, but not an executive. And Nancy Roman is both a manager and an executive. So we've made a modification to the code. The code works, but we've introduced bugs into an existing system, and we've endangered what we already have working in order to add a new feature. And that's really what the open-close principle, or OCP, is trying to help us prevent. And that's the idea of if it ain't broke, don't fix it. So if it's already working, don't modify it in such a way that you introduce potential new bugs into your system. So let's reimagine how we could do this accounts processor in a way that will allow us to not violate this principle. Now, the first thing I want to do before I just start saying, okay, we're going to implement OCP, I want to think through what really has happened that's caused these issues. Like where have I started to make changes and compromises? And I've changed a lot of stuff. If you've noticed that, I had to change the accounts class. I had to change the employees model. I had to change the person model. And I had to change this program.cs. That's a lot of changes to a system that's already working. So let's take a step back from it and look at, can we do this in a different way that allows us to keep things from changing too much or at all when we bring something new in. Like, for example, if they say, okay, we're going to have technician be a new person type. Well, now you've got to add to the enum. We've got to modify the accounts controller. Again, we've got to modify the employee model and so on. Now, the employee model, let's start there. The employee model, I'm using this demonstration. I'm saying, this is what happens when an employee gets created. And so I'm using this is manager and is executive to identify that, yes, these things are changing as part of the process. But really, that should have been baked in originally. And also, maybe it's not that you have a flag called isManager, but maybe you do some other tasks that we're not really reflecting here, but that you could be doing, like going out and creating different accounts for this manager, or setting up a system in HR to allow them to have direct reports, all that kind of good stuff. We're just representing it by the Boolean isManager and isExecutive. So I'm going to leave those changes because that's just more of an indication for us what's happening. But all the rest of this stuff, this is messy. Okay, and you saw how quickly my really simple application went from simple to messy. So we're going to kind of undo as many of these changes as possible. So let's start off by knocking these people back down to just normal employee. We'll leave the for each console write line because we're going to keep those flags there to tell us what's going on. But then we're going to come over to accounts and we're going to say, you know what? No, get rid of all this stuff here because this is just way too complicated. And we're making too many changes because of a change in circumstances. And in fact, the enum, that's going to go away. We don't need to have the enum, so let's get rid of that as well. And the actual enums class itself, since we don't need that anymore. All right, so kind of back to square one, before the boss came to us and asked for us to make a change to allow managers and then executives. Now, the first real big way to make sure that you can implement the OCP is to not tie yourself directly to classes. And I try to avoid that too much because we're going to get into that really heavily in the D in Solid. Okay, so that's video 5 in this series. But if we're not tied directly to a class, we can make some modifications. And how we do that is by actually creating an interface. An interface will allow us to add on to this with other classes, actually use other classes for implementation. So let's do this. Let's go to the person model. I'm going to show you a quick tip or trick. If I select a class and I hit Control Dot or drop down this little light bulb here, one of the options is Extract Interface. This is really helpful because you've started going on this path of creating a class and you realize, you know what? I don't want to have that firm coupling. I want to have an interface that I work through. And so I extract an interface. And I'm going to call it, instead of iPerson model, let's call it iApplicant model. That just sounds better. I probably should have named the person model the applicant model, but that's okay. I'm not going to change that because that's how we started. And I'm simulating the idea that we come into an application that's already working. And one of the things I wouldn't want to do is change a model's name halfway down the road after it's already working, unless I had a real reason to. So this is going to create the iApplicant model. And if you don't know much about interfaces, I'm going to do a dedicated video to it at some point. I do have a much older video that, sorry about the quality, it's kind of poor, but it's actually for just my on-premises class. I was just doing a quick and dirty, hey, here's interfaces. So you can check that out. It's on my YouTube channel, kind of buried. But essentially what an interface is a contract. And so we're going to create a contract for an applicant model. And it's going to have the first and last name properties. And that's it. It created it for us. So now we have our interface, which again is a contract, and we can actually implement that on the person model, which is already done, which is really nice. So it's okay, the person model is an iApplicant model, or implements the iApplicant model. Not is. It implements the iApplicant model. But there's one more thing I want to do, and that's come over to the accounts controller and do something very, very similar. First, I'm going to say, instead of taking a person model, we're going to take in that iApplicant model. Again, the contract, but that doesn't change anything here. It still all works. But now I also want to do one more thing. I want to create an interface for accounts. So again, I'm going to select it. I'll hit Control Dot this time. Extract interface. So iAccounts, and I'll just have that create method in there. We hit OK. That's now our interface, and Accounts has implemented it. Okay, so we've just extracted interfaces for our two classes, and now the one last thing I'm going to do to kind of make some modifications, I'm actually going to add one property here. And yes, I have to make a modification to my model. It would have been good if I had done this at the beginning, but I didn't think through how to implement OCP. Now I'm coming back here and simulating implementing OCP, and yes, I have to make a modification, but I'm going to make one that should not cause any problems with my existing code. So I say prop, and I'll say iAccounts. And I will say account processor. Okay, so that's going to be my one extra thing. And in fact, I'm going to put this into my contract as well. So let's just actually copy this and go to my contract, which is my iApplicant model, and add it there as well. So now every person model will have an account processor. I'm sorry, every iApplicant model. So for this one, I'm just going to say equals new, and this is going to be the actual accounts. Okay, so that's an actual firm implementation of the iAccounts interface, is that accounts we've been using before. All right, so hopefully I haven't lost you yet, but essentially what I've done is I've extracted interfaces for everything. And then in my person model, I said I'm going to have this accounts processor property, which again, I put in my contract as well. It's an iAccounts, and for the person model, which is again that base employee, I set that to be the accounts class. How is this going to help us? Well, right now we have, again, still tied to the person model, not iPerson model. So we'll work on that. But instead of having this newed up accounts processor variable, we're going to get rid of that. And instead of accounts processor, we're going to say person.accountsProcessor.create person. Okay, so we're using the class instance that's in that class model. Now, I haven't changed anything else yet. I haven't even set this to iPerson model, which I will do. But let's just run this and see that it works. Okay, it works. Everything works as it used to, which is good. That's what we want to do. We don't want to have any disruptive changes. So now let's set this to be the iAccounts model. I'm sorry, iApplicants model. All right, and it's yelling at us, and that's because we have a firm implementation over here. So again, we'll say the iApplicants model. And now we're good. Notice we haven't changed the new person models. Those still go right into the iApplicant model list because they implement the iApplicant interface. How does this help us? Well, now when the boss comes to us and says, I need you to give me now managers. No problem, boss. I'm going to take I'm going to right click on my project and say add class. I will call this manager. All right, or manager model. I'll make it public. And manager model implements the iApplicant model. I hit Control Dot here to implement the interface, and there we go. Now, the one thing it does, which I'm not a big fan of, is it sets the get and the set to have throw new not implemented exception, so we can just take those out. What it's trying to do is make sure we review our get and set to make sure that we don't need to change it to something else. Okay, so there we go. But now, remember in our person model, we set that equal to new accounts. We're not going to do that here. We're not going to go into the accounts class and make changes to it. That's going to stay unchanged. We're not going to touch it. Instead, we're going to right click on my project and say add class. And we're going to call this the manager accounts. We'll make it public. And we'll have it implement the accounts interface. Again, control dot, implement the interface, and there we go. So now I can put code in here for how we create a manager. So we can actually go over to our accounts class, and let's just start with the code we already have. So let's copy this. And I know I hate copy paste, and so don't freak out when I copy paste, because yeah, that's a problem. That's not something you should do unless it really makes sense. In this case, both for speed purposes and also because we want to keep a similar logic. But what that also means right now is since I copied and pasted, this now isn't totally dry compliant. Don't repeat yourself. And so I should be thinking about maybe creating a class with a method that has, base creation. Now I could inherit from a base class, but I don't want to do that in this case. I don't want to have a base class called account and then have, staff account, employee or manager account, and an executive account. But I could do that and have some base logic in the base class and then implement extra logic down here. But the reason I don't want to do that is because I'm thinking there's going to be a couple changes. First of all, for a manager, maybe we want to have something a little different for their name. For example, maybe what we want to do is we want to have them in a different domain. Acme Corp, because they're a corporate. All right. So now I'd have to change that as well. And so that's why I don't want to have that inheritance in place. But I also want to do the output dot is manager equals true. There we go. So now I've created a manager accounts that sets the manager up the way we want during the creation process. Okay, so now in my manager model, I say equals new manager accounts. It still implements that interface, so we're all good. So now over here, instead of person model for Sue Storm, I can say, well, actually, this is a manager model. Notice it still implements the iApplicant model interface, and therefore it goes right in, no problem. If I run this, notice that Sue Storm is now marked as a manager. Okay, so the existing code still works, but now we've added new code and we haven't made modifications, especially not to our account model. That's all stay the same. Account class. That's all stay the same. We haven't changed how it works. Instead, what we've done is we've worked against interfaces, which we're going to do a whole lot more, like I said, as we go on in these practices. But what that allows us to do is it allows us to say, well, instead of having a list of person model, we're going to have a list of iApplicant model. And then you can put any type of model in here, any type of class that implements the iApplicant model interface. So now we can have both a person model and a manager model. And so when the boss comes to us and says, actually, now we have executives. No problem, boss. Right click on the project, add class, executive model. And we're going to make it public. And we'll say this is the iApplicant model. Again, control dot. There's my three things. Again, I'll take these out. I could have copied and pasted from another one. I probably should just because it's kind of a pain to clean these up, but that's okay. This is Microsoft's way of saying, let's make sure you're safe about this. You need to at least look at every one of these things. And that's a good thing. They're trying to get you to look at all these things and make sure that you've done them right. Okay, so now I need to, again, right-click on my library, or I'm sorry, my project, and say Add Class. And I'm going to call this the Executive Accounts. So this is going to create executive accounts instead of manager accounts or regular people accounts, whatever they're called. Just accounts. There you go. So just accounts. So this is the iAccounts interface. So I implement the interface, and we have, let's go to accounts. We're going to grab the same, again, this just shows me I needed to have some dry work done. We're going to cover that in another video. But if you have this copy paste going on, at least think about how you can eliminate that as much as possible, if not entirely. Sometimes you just have to have the same code more than once. It's okay. But if you're doing a lot, or if you don't have a great reason why you're doing it, then you probably should look at refactoring. But again, this person is Acme Corp, but because they're, such bigwigs, we're going to use their first name dot their last name. So instead of having it be, T. Corey, or it's going to be instead tim.corey@acmecorp.com. And again, we're going to say output dot is manager equals true. Output dot is executive equals true. Notice I'm not endangering any of the existing code. All I'm going to do is change this person to be an executive. So executive model. So Nancy Roman is now an executive. With that change, if I run this, I throw an exception. Excellent. Anybody catch why? All right. Think about it for a second, and then I'll show you. All right. Go back to the executive model. I set up this iAccount account processor, but never actually initialized it. Equals new executive accounts. All right, that's what actually does the processing of the account. Now this time when we start it, Tim Corey is not a manager, is not an executive, and his email address is tcorey@acme.com. Sue Storm's email address is sstorm@acmecorp.com, and she is a manager but not an executive. Nancy Roman has the email address of nancy.roman@acmecorp.com, and she's a manager and an executive. So that's how we can implement the open-close principle. The idea that we're not going to dip into accounts and start making changes every time we have a difference of what we want to do. So, this used to create just base accounts, and then we add managers, and then we add executives. We shouldn't be coming back in here over and over again, making changes. If we are, that's what we call a code smell. The idea that there's a problem here. So instead, we work off interfaces. And interfaces allow us to change out the actual implementation. So for the accounts, we now have just the accounts implementation. We have the executive accounts, and we have the manager accounts. Each of these does something different in the create method. And yet all can be called by saying, iAccounts.create, because that interface says, yes, this is the contract. They have a create method. And on the person side, we did the exact same thing. Instead of having person model, we're now iApplicant model. And that's extracted away. So we don't really know, is this person a person model? Are they a manager model? Are they an executive model? Doesn't really matter, because we know they implement this contract. And this contract says they have a first name, a last name, an email address, an is manager, and an is executive. And so because of that, they have a first name and a last name, and that's it, right? Yeah. So because they have those two things, there you go, and the account processor. Because they have those things in the contract, we can use those right here to build our employee model, which now this is tied to an actual model. This is not tied to an interface. That might be something I'd go back and change, but for right now, it's okay. So I hope you followed along. This is a little bit more of a complex example because I wanted to get beyond just the examples that are really neat and tidy and don't really fit. Because when you get into the real world, this is the kind of stuff you're going to run into. You're going to look at it and go, oh man, this is a mess. And how do I ever implement OCP in this situation? The first thing is, let's take a step back. Breathe. Think it through. Look at what's going to have to be changed every time one of these situations comes up. And then think through, is there a way I can stop this really tight coupling of, this used to be person model. And so how can we stop this tight coupling so that we can do things like have a manager model or executive model instead of a person model? So we never change person model again. And so the same thing can be true for our account processor. How can we disconnect that from a specific implementation and allow us to say, well, for just a person model, that's the accounts class, but for an executive model, that's actually going to work on the executive accounts system. Now, one thing you noticed is this stuff really got, I wouldn't say more complicated. I mean, it did, but it got more larger as far as files go. We now have a bunch more files we used to. First of all, I wouldn't keep them all here. And in fact, let's do some cleanup here. So I'm going to right click and say add folder. This first folder, I'm going to call, let's call it accounts. And then I'm going to drag accounts in there, and I'm going to drag executive accounts in there, and I'm going to drag the manager accounts in there, and even the I accounts into there. And then I'll right click again on the project and say add folder. And this one we're going to call the applicants. And I will drag the employee model. I'm sorry, not the employee model, the executive model, the I applicant model, the manager model, and the person model. All right, so now that's a little more organized. So now when we're talking about the account processors or how we create accounts, that's all in the accounts folder. When we're talking about different types of applicants, that's in the applicants folder, including their interface. Now you could put all the interfaces together, but I find that just grouping things by type doesn't really give you a whole lot of benefit. There's some, but I really like to have the things that work together close to each other. Now, one thing to note, and before I go on, this is just one of those side notes that it's going to help you because you're probably going to stumble across this if you use this system. Let's say I'm going to create a new type of applicant called technician. So I'm going to right click on the folder now and say add a class. I'm going to call this the technician model. And I'm going to make it public. And it's going to implement the I applicant model. Now, instead of doing the control dot here, I'm going to learn from my previous issues and just copy and paste. And now that satisfies the contract. And let's pretend for a minute that the technician doesn't have a different processor yet. So we'll leave that alone. The one thing I want to point out let's do a comparison. Let's close all the others first. Let's do a comparison between this and the person model. I'm going to put them up on top of each other. So new horizontal tab group. Okay. Do you notice anything different about these two models? I know it's a little tight here, but take a minute to look at this. There's one change that is significant, and that change is the technicians model up here. The namespace is ocplibrary.applicants. Down here, it's just OCP library. And the difference is, did I drag the item into the folder, or did I create the item in the folder already? So because the folder already existed, and then I created this item inside the folder, it changed the namespace to include the folder. So now it's OCP library, which is the project name, and then applicants, which is the folder name, and then your class. That may throw you for a loop sometimes. Just make sure that you know the difference between the two. But here's the cool thing. Namespaces, you can change them. Okay? So I decide, you know what? I want them all to be the same. Or maybe I go the other way and say, I really want to have that structure, so I'll do it for all the items in this folder. So I'll go back through and change all of these to say .applicants. So it's up to you. Just know that we'll mess with your using statements. You'll have some issues there. So just think that through how you want to do it, but just note that it will be different if you create something new in here versus if you create at the root and then drag it in. Okay, so that's the open-close principle. It talks about the idea of being open to extension, but closed to modification. So and we really focused on the accounts part of this, the account.create. So our accounts class, initially when we started making those changes, we changed everything. Okay, we modified this. We had if statements and switch statements, and we're changing things left and right. We're introducing bugs and all the rest. But when we went back and kind of redesigned a piece of this application, so we actually had to modify some things. But once we did, now our accounts class doesn't have to change ever unless there's a bug. And instead, now it's closed for modification, but it's open for extension. So the idea is if we add a new type of account where it's processed differently, we can use the interface to allow us to bring in a new class that uses the same structure but has those new features. This is not the only way to implement the open-close principle. We could have, like I said, create a base class and then have different things inherit from it and said, okay, accounts implements is a child of this base abstract class called maybe account, singular, or account processor or something like that. And then we have, the base account, we have the executive account, we have the manager accounts, and they all implement from that one base class. That's another way of doing it. I'm not as big a fan of that, usually because it doesn't give you as much flexibility as, say, the interface method does. With that being said, it's not about the concrete way you do this, because even different languages may handle things differently. It's more about the concept. And the concept is we don't modify the account class. Instead, we extend it or we change it or we either inherit from it or we use the same interface so that we can grow our application and add new features without changing working code. Now, one thing I want to point out is that this really works hand in hand with our first video in the series on Solid, and that's the single responsibility principle. Instead of having a class who is responsible, like accounts was becoming for this create method, it was becoming responsible for creating regular employees, managers, and executives. So it would change for 3 different purposes. It would change if the way we create normal employees changes. It would change if the way we create managers changes. And it would change if the way we created executives changed. And so now what we've done is we've separated those into 3 separate classes: accounts, executive accounts, and manager accounts. And now each of these will only ever change for one reason. And that's if the way we create, say in this case, an executive, the way we create an executive changes. That's the only reason we'll change this. So now we are better implementing single responsibility principle, and we're also implementing the open-close principle in that these things don't change when new features get added. All right, so that's it. That's OCP. My encouragement to you is to practice. I know this can be a little bit complicated sometimes. I know it can be a little daunting to see, oh my goodness, there's tons of changes. Yes, that's because I wrote the application poorly, and I had to make some changes to allow it to implement OCP correctly. Once I did that, then there wasn't all these changes. I mean, you should probably feel pretty confident right now in adding that technician, because all you do is create a processor for the accounts, and then instead of an executive model or a person model, we say technician model, and we're done. That's it. So this really allows us to make our applications more robust, and it allows us to be more confident in the code we write. And all the code we're writing is very, very small. We're just making small changes based upon our new circumstances. So I hope you've enjoyed it. Practice, practice, practice. The more you practice this, the better off you'll get, the more comfortable you will be starting off with OCP already in your code, and also SRP. Don't forget that one. So these 2 things implement your code will be cleaner. It'll be more streamlined and be more future-proof when it comes to changes. I hope you've enjoyed it. Leave me a comment down below what you thought. And as always, I am Tim Corey.